someone tell me how we add fractions? What do we have to have? Common denominator. So what's my common denominator going to be? 10. So if my denominator is 10, what do I have to multiply my first fraction by to get 10? 2. So I'm going to multiply by 2. And my second one? 5. So I've got 6 plus 5. So that's 11/10. Okay. So same thing for my second one. What's my common denominator going to be? Ooh. 24. Good. I could say 48, but then I'd have to simplify. So 24 would be better. And what am I going to multiply the 8 by? Times 3. And what am I going to multiply the 6 by? Times 4. So I've got 9 minus 20, which is negative 11? 24ths. Still get 11. And then how do I multiply fractions? Straight across, right? So 4 times 1 is 4, and 5 times 8 is. And then I simplify and I get 1/10. Beautiful. And then how do I divide fractions? Which one? The second one. Good. I'm going to flip this one, right? So I get 7/3 divided by 39/35. Oh, not divided by. Whew. Once I flip it, it becomes times, right? 39/35. And I'm going to simplify before I multiply because, right, this 7 times 39, I don't even know what it is, right? But I know that 7 goes into 35 how many times? 5 times. And 3 goes into 39 how many times? 13. So now if I multiply, I get 13/5. You were close. Oh, nice. Okay. Any questions on that? We're not really going to do a bunch of adding and subtracting of fractions, just so you know, but I just wanted to see if you guys could do it. That's all. Hope you remember. You guys are like, dang it. Huh? Awesome. The multiply or the add? Add and subtract. So we're going to go ahead and move on. Sorry, I have to make it smaller so I can read it on the iPad. So our first thing we're going to do is solve equations, right? Super easy. How many of you can solve equations? Most of you got one person. Awesome. Okay, good. 2 people. So I know you can because it was on the Kahoot, right? Solving equations. You guys did it. So we have our essential question is, what are the 3 different types of solutions for a basic equation, and how do you tell them apart? That comes at the end. Okay. The first thing, our first vocabulary word is equivalent equations. These are equations having exactly the same solution, like 2x equals 16. If I solve, I get x equals 8. And 3x plus 5 equals 29. If I solve that, I'm going to get x equals 8 also. Okay. Equivalent expressions, a string of numbers, variables, mathematical operations, and possibly exponents. As long as when I simplify them, they are exactly the same. The main difference between an expression and an equation is an equation has an equal sign. That's it. Okay? Expression does not have an equal sign. An equation has an equal sign. Okay? So, on the next little part here, I want to know if you can classify an equation or an expression. Classify each of the following as either part of an equivalent equation or a pair of equivalent expressions, or neither, which means they're not equivalent, right? So I have to check to see if they're equivalent. So if I do number 1 here, I'm going to solve first. I know they're an equation, right? So I know this is an equation. Why do I know it's an equation? Because it has an equal sign. I'm going to zoom in. So I know it's an equation because it has an equal sign. But now I need to know if it's equivalent. And how I find out if it's equivalent is I just solve for them. So subtract 13. I'm going to try and write small because I didn't give myself a lot of room. 21. Good. Divide by 7. So x equals 3. Beautiful. Divide by negative 17. And x equals 3. So they are equivalent equations. So that's an equivalent equation. Okay? That's it. Number 2, are they equivalent? So no equal sign, so I know that this will be an expression. So I just need to know, the first one's already simplified, that one's already simplified. Does the other one equal the same thing? Well, yeah, 4x minus 9. So this is an equivalent expression. Okay, questions? All right, I want you guys to do the next 4. Just give you a couple minutes to do that. Again, what did you guys get for A?
Equivalent expression.
Good. Equivalent expression. Okay, what about B? Equivalent equation. Wow. And C is the next one?
Equivalent equation.
I thought I put one in here that wasn't, so that must have been D. And of course, we already know D is an equivalent expression because it's the same as 2.
Yeah, never mind, sorry.
Expression, no equal sign. Okay.
Well, isn't like the next step finding out if they are equivalent?
Yeah, it's the same thing. So basically, they just want us, maybe this is where I messed up. Maybe this is what I did. So we want to find out if they're equivalent or not. So these are all equations. I just want to know if they're equivalent. So we're just solving. So 1, right? You guys know how to solve. So add 4 to both sides. 3x equals 12. Oh, they're the same. Now, once I get to this spot, the only thing, it doesn't ask me what the, oh, I should probably put a space in there. It doesn't ask what the answer is. It just wants me to tell whether they're equivalent or not. So once I get them to be exactly the same, do I have to do anything else? No, I don't have to finish it. Does that make sense? So I'm done. Yes, they're equivalent. Equivalent. Okay, so I'm done because I got 3x equals 12 on both of them. I don't have to solve. It doesn't say solve. It just says tell me if they're equivalent. Does that make sense? So number 2, ooh, what do you think? Is number 2 equivalent?
Yes.
Ooh, so how? Tell me.
Because the only common thing that we have is the x, so you would divide the x by both sides.
So I divide by x here, and I divide by x here, and I get what? 3 equals 4. Okay, so what about the other side?
Sorry, it's wrong.
I can divide by x. I'm just going to say, I can still divide by x, right? That's the same as multiplying by 1 over x, right? So if I divide by x, that's 1 over x. That's not going to do anything. The problem is, if I multiply by x, I can get rid of the x's on this side. I just want to know, and I can get 3 equals 4. The issue is, it should be for every x. What happens if x equals 0?
It's undefined.
It's undefined. So can this one be 3 equals 0 at x equals 0? Can this equation be this where x equals 0? It can't, right? Because if 0 is in the denominator, what do I get? An undefined function. I cannot have x. There can never, ever, never, I'm going to write this out, ever be a 0 in the bottom. Right? Never be a 0 in the denominator. So this is not, it's equivalent in a lot of places, okay? But not in the, but not when it's 0. Equivalent. Ooh, I can't spell. Not equivalent. Okay, you do the next 2. A, what is A? Equivalent or not? Huh? Equivalent. He's like, it is equivalent. What does T equal? What the heck? Sorry. I went to highlighter instead of pen. I know. Equivalent, they both equal 7. Good. And B? Not equivalent. Not too bad so far, you guys? First page. 24. 24. So what do I multiply 8 by? And what do I multiply 6 by? And then I get 9 minus 20, which gives me negative 11/24. It's just like adding, only I'm going to subtract the top instead of adding. That's it. Okay, and how do I multiply fractions? Oops, sorry. How do I multiply fractions? Anybody?
Do you find a common
Multiply across. So I'm going to multiply this way and this way. So I get 4 over 40, which simplifies to 1/10. Beautiful. And how do I divide fractions? Of which one? The second one. Beautiful. So I'm going to take the reciprocal. And what is a reciprocal? Great. I flip it, and then it becomes a multiplication problem. And I'm going to go ahead and simplify before I multiply. You can multiply first and then simplify, or I could simplify and then multiply. On this one, I'm going to simplify first. So 7 goes into 35 5 times, and 3 goes into 39 13 times. So my answer should be 13 over 5. Okay, not too bad. Just a quick review of how to add, subtract, multiply, and divide fractions. Okay, so we're moving on. We're going to be solving equations today. That's just horrible. Okay, so we're going to talk about the difference between equivalent equations and equivalent expressions. Equivalent means I have 2 of them, and they have to be equal or the same, right? So if it's an equation, when I solve it, it has to have the same answer. Both of them have to have the same answer. If it's an expression, when I simplify them, they have to be identical, exactly the same. Is that okay? Right? And the difference between the two, between an expression and an equation has an equal sign, and expression doesn't. That's the only difference. Does that make sense? So that's just our little definition and the difference. So we're going to go down here to, can you classify them? So I want to define, oh my Lanta. I want to first decide if it's an expression or an equation, and then I want to know if they're equivalent or not. So on number 1, is it an expression or an equation? Why? Because there's an equal sign. Right, it's an equation. Because there's an equal sign, it's an equation. Now I need to know if it's equivalent. How do I tell if it's equivalent? You solve. Yeah, exactly. I'm just going to solve. So minus 13, and I get 7x equals, ooh, that doesn't look like a 7. Equals 21. Yeah, I can subtract. So x equals 3, divide by negative 17. And again, x equals 3. So this is equivalent. Equivalent. There we go. So it's an equation and it is equivalent. Okay? Questions so far? Guys, if you have questions, make sure you ask. I will answer your questions as many times as you need me to, usually. I think a few of you have had me before. I do that. Okay, number 2, equation or expression? Expression, great. And is it equivalent? Expression, sorry. I'm not the best speller. I can't talk and spell at the same time. So the first one is already simplified, and the second one simplifies to 4x minus 9. So guess what? They are equivalent. Equivalent. Beautiful. So now you guys are going to do the next 4. So go ahead. I'll give you A. Great. Equivalent expression. Beautiful. It's okay if I just abbreviate it. Okay. Number B. Equivalent equation. Okay. And C. Equivalent equation. And then, of course, I think D is the same because I made a mistake. So it happens. And then, of course, it's an equivalent expression, right? I thought I'd fixed all my mistakes, but obviously I hadn't. Okay, So the next one, we're just going to determine if they're equivalent or not. They don't care if it's an expression or an equation. Of course, they're all equations. They just want to know if they're equivalent or not. So I have to solve. That's it. So number one, I'm going to add 4. And I get 3x equals 12. Okay, I can stop. I don't need to solve it. It just wants to know if it's equivalent or not. When I get to a point where they're identically the same, guess what? I can stop. Because it doesn't ask me to solve. It just asks me to tell if they are equivalent or not. So this is equivalent. And I probably totally just spelled that wrong. That's why I teach math. Okay, 3x equals 12 and 3x equals 12 are the same. So second one is a little bit harder to deal with, okay? So, trying to remember how I want to deal with this. Is there any value, let's talk about this, where one of these equations is not true? Let's just stop there. Is there any value for x I can't use it in either one of these equations? That's a good question to ask. Okay, let's start with the first one. In this one, is there any value of x I can't use that would make this false? 1. 1 works. 1 makes it false. Anything makes it, any value of x makes it not true, right? 3 will never equal 4. What about here? But basically, what value can I not use here in this one? There's one value I absolutely positively cannot use ever. What value is that?
0.
0. Why?
Is it be 0?
Can I have a 0 in my denominator? No. What happens when you divide by 0? What? Not true. Yeah. If you go in your calculator and divide by 0, you get what's called undefined. They say undefined or error, depending on the calculator you get. So you can never, ever divide by 0. If you remember, I know I'm stretching and asking you guys to remember last year. If you had, when we were doing rational functions, right? If you had a 0 in your denominator, it gave you an asymptote, right? Because it didn't exist there. So these functions do not exist when there's a 0 in the denominator. So are these two equations equivalent? Can they ever be equivalent? This one I can divide by x, right? And I get 3 equals 4. Is that equivalent? No, that for sure is not equivalent. And I can kind of do something like that over here. And I can multiply by x, right, on both sides. That gives me rid of my x's. And I still get 3 equals 4. But is that equivalent? No. So are they equivalent? No.
Did we have this class during like summer or something?
No.
Like, am I missing something? This is like confusing.
What? Knowing if something's equivalent or not?
Like, I don't remember doing any of this.
This was probably your freshman year. That's why you don't remember it. Okay? Honestly, this is way back freshman year.
So why are we...
Because college prep math covers everything from your freshman year to your junior year. Here we go. So what about A? Equivalent, good. Equivalent. And B? Not. Okay. All right. We got 2 more to go. Okay. We got a couple more vocabularies. I hope you can combine like terms. That's what we're doing next, right? A term is a number, a variable, a product of numbers and or variables, a quotient of numbers and or variables, and they're separated by plus or minus signs. What does product mean? Multiply, good. This means multiply. What is quotient? divide, beautiful. Okay, so an example is 8x to the 5th plus 17 minus 4 over x minus x cubed. Each one of these is a term. This is a term, that's a term, that's a term, and this is a term. So I have 4 terms in that. Okay, combining like terms is, like terms have the same variable raised to the same power. Very important. It's the same variable raised to the same power. Okay, and combining like terms is adding or subtracting those terms together. So here we go. Sometimes we have to do some other stuff first before we can combine them together, but here we go. 1. So I'm going to find my like terms. I know that 5a squared and a squared are a like term, and 3a and negative 7a are like terms. So if I combine my like terms, I have 5a squared plus a squared gives me 6a squared. Good. And 3a minus 7a gives me minus 4a. And I'm done. That's it. I know. Okay, what do I have to do first to number 2? What do I have to do inside the, is there anything to do inside the parentheses? No. So what am I doing with the parentheses? I'm distributing the negative. Good. So I'm going to take that negative, I'm going to distribute it through. So I get 8x minus 9 minus 7 plus 5x. Identify your like terms. So luckily those two are together. So 8 plus 5 is 13 minus 16.
And does it matter if you like swap them?
Nope, it doesn't matter as long as the signs are correct. As long as the signs are right. Although standard form for anything in math is the highest exponent to the lowest exponent. It doesn't have to be that way. Okay, but that's just standard form. Okay. Okay, so what about number 3? What am I going to do first in number 3? Oh, I know. There's 2 sets of parentheses. So there's a parenthesis and a bracket. I'm going to start on the very inside. So that means I'm going to start with, negative 5. Good. I'm going to start with there. So I'm going to distribute that negative 5 through. And I'm just going to go ahead and do the negative 3 so it takes care of the outside, right? So I've got negative 3b minus 6 minus 9. And then that's minus 40b plus 5. And then I have to do what? Distribute the negative. Very good. And I get negative 3b minus 6 minus 9 plus 40b minus 5. If I identify my like terms, I've got my b terms that are, and then my, just my numbers. So I get, what do I get? 37b and negative 20. Good. There you go. Questions? You guys remember how to do this? I know it's been like a long time. That's why we're starting out easy. Okay, you have 4 problems. A, B, C, and D. Sorry, I'm going to put them up here so you can see them. Okay, what is A?
It's 15.
15A, right? Awesome. So what about B? 4t cubed.
Minus 5t squared. Plus 2t.
Now, if you have your terms in a different order, it's okay as long as you have those terms, right? Okay. So now let's go to C. Notice we're getting a little harder as we go down, right? Okay, you're like, yeah. Okay, C. What is C? Negative 2x plus 22. Okay, do I need to go over? If you need me to go over them, let me know. Okay. And lastly, D.
Negative
10x minus
30.
Oh, so I was right.
Everyone okay with that? Do I need to go over that one? Yeah? Okay. So I'm going to erase it real quick. So I'm going to start with the -4, right? And go through, distribute that. So I've got 5, -2x plus 3 times 2 minus 20x minus 4. Okay? Now I'm going to distribute the 3. So then I've got 5 times -2x plus 6 minus 60x minus 12. And then distribute the 5. So I've got -10x plus 30 minus 300x minus 60. Combine your like terms. -310x minus 30.
Yeah, I did.
If I would've-
Yeah, if I would have just not.
She is going to keep on top of you.
My ear's gonna fall off.
Okay, so now we're going to go on to solve. And solving multi-step equations, which means more than one step, right? So on number 1, what do I do first? Distribute the negative. Beautiful. So I've got 8x minus 3x plus 5 equals 40. And then I'm going to combine my like terms. So I've got, and I'm going to kind of do this all in one step. Okay, I'm going to subtract 5 from both sides. And then I'm going to add 8x minus 3x gives me, what does that give me? 5x equals 35. Divide by 5. X equals 7. Not too bad? Okay. Something easy for you. If I'm going too fast, also, you guys make sure you just let me know, and I'll go backwards, okay? Let's go over here. Okay, now we have some fractions. I'm still going to distribute. No, I'm not. I'm not going to distribute this because 4 does not go into 6. That's ugly, right? 3 doesn't go into 4. I'm going to get rid of my fractions first, right? So what does both 4 and 3 go into? I just gave you the answer. 12. So I'm going to multiply my whole fraction by the whole equation by 12. I'm just going to change everything, multiply by 12. That's going to get rid of my fraction. Okay? So 1/4 of 12 is what? 3. So this becomes 3 times 6t plus 48. Because I'm multiplying, I don't have to change anything inside my parenthesis. Minus 20 times 12. 240? 2 times 12 is 24, right? Yeah. Okay. Equals 1/3 of 12 is 4. So that'll be -4. Good. -4 times 4t minus 72. No more fractions. Is that problem easier? Yeah. Okay. So now I can distribute the 3. And I get 3 times 6 is 18t plus 3 times 48. That should be 150 minus 6. 48 times 3, 144. I was right. Minus 240 equals -16t plus 72 times 4, 288. Wow. Okay, so I've got 18t, 240 minus 144 is 96. Equals -16t plus 288. So I'm going to add 16t. And I'm going to add 96. And that gives me, what does that give me? 34t equals plus 288. 384. Divide by 34. I don't think that goes in there, by the way. T equals, divided by 34. Oh, I hit the wrong button. 384 divided by 34 gives me 11. I'm just going to put it in decimal form. I shouldn't. I should just simplify it, but I'm not. 29, 11.29. Okay? I think that it is in fraction. By 2, 192 divided by 17. Half of 34 is 17, so that's what it is in fraction form. 192 divided by 17. Sorry. That was ugly. That's the ugliest problem, by the way, on here, so you don't have any like this to do in your next 4 problems. You have a similar one, but not as big of numbers. Okay, so we've got 4 problems for you to do. A, B, C, D. For letter A. I actually said letter. Wow. Usually I say number. Okay, letter B. Y equals 5. Beautiful. Okay, letter C. X equals 4/5. Everyone okay with that? Okay, and D. Equals what?
8/5. That's correct.
I did not get 8. Yeah,
I got 3.8.
that's probably right. I got 19/5.
It's the same thing.
Yeah, that's why I was like, I think that's right. 19/5.
Wait, you got a positive?
Yes.
Will you walk through?
Yes. So let me erase that. So what I did is I multiplied the whole thing by 12, right, to get rid of my fractions. So I ended up with 8 times x minus 2 minus 12 equals 3 times x minus 3. How did I get 8? Can anyone tell me how I got 8?
Oh,
How many times does 3 go into 12?
I can tell you.
Okay, go ahead, George.
So what I did, I multiplied the 2 by 12 and then just did it.
Oh yeah, that works too. 3 times 12 is 24, divided by 3 is 8. Good. Yeah, perfect. So distribute, so I get 8x minus 16 minus 12 equals 3x minus 9. And then I added 16 and added 12. I just didn't combine them, sorry. I'm just doing it how I did it. So subtract 3x, subtract 3x. And I got, 5x equals 19. Divide by 5. Yeah.
I just forgot to turn the negative 1 into.
Oh, yeah. You have to distribute that 12 by everything. So 1, 2, and 3.
I made my mistakes on there.
The adding and subtracting part. I know. Okay, so page 2, this is something that, that was good. I didn't get it all the way erased. Something that you should have already been able to do. Okay, Yeah, we're going to talk about combining like terms, and a variable term means a number, a variable, a product of numbers, or variables, or a quotient of numbers and or variables, and they're separated by plus or minus signs. So each one of these is a term, right? Term. There's 4 terms in that expression. Each one is a term. Okay, like terms have the same variable. The same variable raised to the same power. And combining like terms is adding or subtracting those terms together. So you should have done this probably in all the grades, because you had to combine like terms in every grade forever, right? So I'm going to identify my like terms, and I just kind of like circle or underline the same like terms. I guess it kind of helps me. So I'm going to underline my like terms and then circle my other ones. If you have more than one, you come up with creative ways to identify them, I guess. And then you combine them together by adding or subtracting them. Notice there's no equal sign. I'm not changing the sign. I'm just adding or subtracting them together. So 5a squared plus a squared gives me what? 6a squared. Very good. And 3a minus 7a gives me negative 4a. And that's it. Done. Okay? So what do I need to do first for number 2? And how am I going to get rid of the parentheses? Multiply by the negative. Awesome. So I'm going to multiply by the negative. I'm going to distribute that through. So I get 8x minus 9 minus 7 plus 5x. And then I'm going to identify my like terms. So 8x plus 5x is 13x. And negative 9 minus 7 is negative 16. Done. I think I have another problem. Oh, good. Okay. What do I do first on number 3? Ooh. Which parentheses? So the bracket, let me just say this bracket right here is also a parenthesis, right? I just have something inside, so I'm going to start on the very inside. If I have more than one bracket symbol or grouping symbol, I'm going to start on the very inside and then work my way out. Does that make sense? So I'm going to distribute the negative 5 first. And I'm just going to go ahead and do that because the negative 3 is just by itself. So I'm going to do that one. So I've got negative 3b minus 6 minus 9 minus 40b plus 5. And then I only have one parenthesis left, so that's the negative, which I'm going to distribute again. So I've got negative 3b minus 6 minus 9 plus 40b minus 5. Find your like term. So I've got the b's and the constants together. And that gives me 37b minus 20, I believe. Questions? Is that okay? All right, so there's 4 questions. You guys go ahead and work on those A, B, C, and D. 15A, good. And B. And let me get over there again. B. Not D, B. B.
B?
B, as in boy. Or Brad.
Is it negative
So is this like homework?
5t squared plus 2t plus 4t cubed?
Very good. So 4t cubed, and it doesn't matter what order you write this in as long as you have it. 5t squared plus 2t. Just a standard way to write it is from highest exponent to lowest exponent. If you wrote your terms in a different order, that's fine. Yeah, funny.
Are you sure it's negative? I think they're all positive. Or is there a negative?
No, I'm pretty sure that this is a 7t squared plus 2t squared is negative 5.
Okay.
Negative 7 plus 2 is positive 5, right? Okay. How about C?
Negative 2x plus 22.
Negative 2x plus 22. And D. Now it's D as in dog.
Negative 310x minus 30.
If you guys ever need me to do, ooh, lovely, any of these, please let me know. Does anyone want me to go over that last one? Is everyone okay? Yeah? Okay. So, right, I start on the inside. So I get 5 minus 2x plus 3 times 2 minus 20x minus 4. And then I'm going to distribute the 3 through. So 5 minus 2x plus 6 minus 60x minus 12. Distribute the 5 through. Whew. And I get negative 10x plus 30 minus 300x plus 60. So I get negative 310x, right? This one and this one. And then my like term, oh, this is negative 60. Wow, minus 30.
Oh, it's gonna be a long year of math.
Probably, but you need to pass, right?
Yeah. You're
Okay.
good with a lot of questions, huh?
Huh? Okay, so the next thing is we're going to solve multi-step equations. You guys have all solved before, right? We did it on the Kahoot, so you should be okay with this. How am I going to solve number 1? What do I do first? I distribute the negative. Awesome. So I get 8x minus 3x plus 5 equals 40. So I'm going to subtract 5 from both sides and add my like term. So 8x minus 5x gives me, sorry, that's 8x minus 3x. Wow. Thank you. And that equals 35. So if I divide by 5, what does x give me? 7. Good. Sorry, I gave you the answer instead of what the question said. Okay, not too bad so far. The next one's a little harder because it involves your favorite thing in the world, fractions.
Oh, I love fractions.
Good. I'm so glad, Ben. So I can, now I'm going to look at my fraction and my parenthesis first. If 4 goes into both 6 and 48, I would distribute it. Does 4 go into 6 and 48? No, it doesn't, right? So I am going to get rid of my fraction first. I want to get rid of my fraction so I don't have to deal with it, okay? You guys okay with that? So how I get rid of fractions is I multiply by the denominator, my common denominator. So what's the common denominator between 3 and 4? 12. I'm going to take this and multiply the whole thing by 12. Everything by 12. Every term. There's only 3 terms, okay? And it's this term here. Oh, that's the erase button. There's this term here. There's this one, and there's this one. Okay? There's only 3 terms. I'm only going to multiply it 3 times. Okay? So what's 12 times 1/4? 1 times 12 is 12, and divided by 4 is 3. So that gives me 3. And then I have 6t plus 48. What's 12 times 20?
20.
Yeah, 20.
Yeah.
Okay, what's 12 times 2? Add a 0 on the end.
240.
240, yeah. Okay, what's a third of 12? 4. And there's a negative out front, so I have to have negative 4 times 4t minus 72. This is a little easier problem, right? Because now there's no fractions. And now I'm just going to do what I just did on the last problem. Distribute, combine like terms, solve for, what's my variable? T. Okay? So 3 times 6 is 18t. And 3 times 48 is 144? Thank you. Minus 240 equals negative 16t, negative 4 times, and negative 4 times negative 72, is it? 288, thank you. 288. Okay, so then I think this is 18t minus 96. It's minus 96, right? Yeah. Equals negative 16t plus 288. So I'm going to add 16t to both sides. And then I'm going to add 96 to both sides, right? If I can write 96. 96. So this gives me 34t equals, that's a 4, carry the 1, that's an 8, carry the 1, 384 divided by 34. I did that in my head, so I hope it's right, you guys. t is going to equal, what's half of 384? Half of 38 is 19, so 192/17. Yeah. Unless 17 goes into 192, but it doesn't. I just remember from last class. Okay. You guys have 4 problems again, A, B, C, D. The one with fractions is a little bit easier. I'm going to leave that one up here though, so you can kind of see it. Can you see it? Kind of see it. Let's start the recording. What is A? T equals 6. What is B? Okay, please let me know if you need me to go over any of them, right? Y equals 5, is everyone okay with that? Remember, I'm only distributing the negative sign, not the 5. The 5y is not touching my parenthesis. Okay? All right, so C, x equals 4/5. Anyone need me to go over that one? Okay, so I'm going to combine my like terms on each side of my equal sign first. So I get 12x minus 2 equals 2x plus 6. Then I want to get all the variables on one side of my equal sign and all the constants on my other side. Okay? So I'm going to subtract 2x. And then I'm going to add 2. So I've got 10x equals 8. Divide by 10. 8/10 simplifies to 4/5. Okay. And then the last one, how many people just need me to do it? Okay. I'll just do it. Okay. I'm going to multiply by, what am I multiplying by? 12. Great. So 12 times 2 is what?
24.
Divided by 3, 8. So that's 2/3 of 12 is 8. Times x minus 2. Minus, so I multiply by that, by the 1, and by the 1/4. There's 3 things I'm multiplying by. So 1 times 12 is 12. And then a fourth of 12 is 3. Okay, then I distribute again. And I get 8x minus 16 minus 12 equals 3x minus 9. So subtract 3x from both sides to get my x's together. Add 16 and add 12. So to get everything on the opposite side. So I get 5x equals 9. Divide by 5. So x equals 19/5. Questions? Is it okay? Not too terribly bad so far. Just so you know, I'm going to tell you, you don't have any fractions on your homework. Okay?
For today?
Yes, for today.
Is it this?
Yeah.
Okay.
Okay?
Online or on paper?
Online.
That's math.
Yes. Okay. This is the only paper you're going to get mostly from me is the notes. Oh, last page. So now we're going to classify the expressions or the equations. So there's 3 different classifications. One's called an identity, and that's an equation that is true for all replacements or variables, and it equals exactly the same thing. So no matter what I'm solving, I'm going to get the same thing. So I have an example. So if I solve this, I get x plus 5 equals x plus 5, right? Exactly the same thing on both sides. That means no matter what x I put in there, I'm going to get the same thing, right? So this is an identity. Once I get to this spot, because if I still go and solve for x, look what happens. I solve for x and I get 5 equals 5. There's no x's anymore. When I solve for an identity, the x just kind of goes away. Okay, and I'll get 5 equals 5. Or if I subtract 5 from both sides, I'll get 0 equals 0. Okay, I'll just get the same thing equaling the same thing. Does that make sense? Okay, the next one is called a contradiction. And it's an equation that is never true, never ever. And it doesn't have an answer. So if I subtract in here from both sides, I get 0 equals 1. Does 0 equal 1? No. I'll always get something. The variable will disappear. Again, there will be no variable. And I'll get some number equaling some other number. That's a contradiction. Okay? Questions on that? Does that make sense? See the difference in them? And then a conditional equation, looks like I need to put a space in there, is the one that you'll see the most, and that's the one that you do most of the time. You get one answer, right? I get x equals something. So subtract 5, and I get 2x equals 12. Divide by 2, x equals 6, right? That's what we're used to doing. Those are called conditional equations. It's an equation that's sometimes true and sometimes false depending on the value. Well, yeah, it's sometimes true. It's only true when x equals 6. Any other time, it's not true at all. That's a conditional equation. Okay, so we're going to find each solution set, then classify each equation as a contradiction, an identity, or, conditional equation. Wow, I can't read either. Conditional equation and an identity or a contradiction. So we're just going to solve them, and then we're going to say what they are. That's it. So if I distribute this through, I get 4 plus 7x equals 7x plus 7. I'm going to subtract 7x, and I'm going to subtract 4. So I get 0 equals 3. What type of solution is that? Contradiction. Good. There's no x. X is gone.
I wasn't talking about that one.
Oh, okay. I'm like, there's no 0. And then, hi, Shalali.
Drive me out.
Huh?
Drive me out.
No. Go to class.
I'm just kidding out.
Okay, so I'm going to distribute this. This is 3 times 7 minus 14x plus 8 equals negative 40x plus 45. Distribute again. 21 minus, let's see, 42x plus 24 equals negative 40x plus 45. Wow, okay. Negative 42x plus 45 equals negative 40x plus 45. So I'm going to add 40x. Subtract 45. And I get negative 2x equals 0. So x is going to equal 0. So what type of solution is this? Huh? Conditional. Good. No, it is not. An identity would be 0 equals 0 with no variable left. Okay? A conditional has x equaling something. Okay. Okay, go ahead and do identity. Oh, if I can spell. I can't. There we go. And 3. Conditional. And D is the same as 1, so it's a contradiction. Okay. So the next thing we're going to talk about is classifying equations. Okay. So there's 3 different classifications. There's an identity. An identity means it equals exactly the same thing. There's no x's left. When I get done solving, the x's are all gone, and I get the same number equaling the same number. Okay? So I have an example here. It says x minus 5 equals 3 plus x plus 2. So if I'm going to solve this, I'm just going to zoom in. So x plus 5 equals 5 plus x, right? Subtract x from both sides, and I get 5 equals 5. I get the same thing equaling the same thing. It's an identity. No variable left, right? The variable's gone. X minus x is 0. X minus x is 0. So the only thing I have left is 5s. Are you okay with that? If I get down there, there's no variables left. I have an identity. Okay? The next thing is a contradiction. Contradiction says it's an equation that's never true. It doesn't have an answer. I'll get the variables gone again. There's no variables again. And I get some number that equals some other number, right? They're not equal. So if I do this example again, I subtract n from both sides, and I get 0 equals 1. Well, does 0 equal 1? Never in any universe does 0 equal 1. So that means this is a contradiction. Okay? Sorry. I don't know what happened to my screen today. Okay? And then the last one is the one that you use all the time. You just didn't know it had a name. And the name is a conditional equation. It's an equation that's sometimes true and sometimes false, depending on what the answer is. Right? Almost every equation you solve is a conditional equation because it has an x equals something. So if I solve this equation, minus 5, I get 2x equals 12. Divide by 2, I get x equals 6. It equals something. Even if it equals 0, I get x equals 0. I still have a variable, and it equals something. Whether it's a fraction, or 0, or infinity, I have x equals something. That's a conditional equation. Does that make sense? Okay, so I have 3 different ones. Identity and contradiction, no variables left at all. They're gone. Okay? Identity, same thing equals the same thing. Contradiction, I get a number that equals some other number. Can't be true. And then conditional statement, x equals something. Okay? Does that make sense? So what we're going to do is we're going to find the solution and then classify it. I want to know if it's a conditional equation, identity, or a contradiction. Okay? I want to know what it is. So we're just going to solve. Okay, so number 1, what do I do first? Distribute, good. So I have 4 plus 7x equals 7x plus 7. Now what do I do?
Minus 7x?
Minus 7x, beautiful. And I get 4 equals 7. 4 does not equal 7. Contradiction, good. And it's Allen, right?
Yeah.
Okay. Contra. Oh, and I put a D instead of a T. Wow. Let me try and fix that here. Contradiction. There we go. Yeah. Because I spell super well, you guys. Don't laugh, Sophie. Okay. So now we're going to go to number 2, right? Oh, it's a little harder problem. Everyone was complaining that I gave you guys the easy ones to do, and I left the hard ones. I mean, I did the easy ones, you guys did the hard ones, so I kind of flipped them around a little bit this year. So I gave myself a hard one to do. So we're going to solve it, right? Where do I start at? The parentheses. So I'm going to distribute the negative 2 first. So I've got 3 times 7 minus 14x plus 8. Yeah, that's it. Equals negative 40x plus 45. Beautiful. Now I'm going to distribute the 3, right? Okay, so I've got 21 minus 42x plus 24 equals negative 40x plus 45. So I get negative 42x plus 45 equals negative 40x plus 45. So if I add 40x to both sides, and then I subtract 45 from both sides, I get negative 2x equals 0. Then what am I going to do? Divide by negative 2. Beautiful. What's my answer? What does x equal? 0. So is this a contradiction, identity, or conditional? Conditional. Very good. Conditional. Because x equals something. Even if it is 0, 0 is still something. Okay, so here we go. What is the answer for A? What type of contradiction? Good. Whoa. Okay, let's try with a pen this time. Contradiction. If you guys need me to go over any of these, let me know. B is a what? Identity. Good. And C is a conditional. Good. Conditional. Because you get x equals 0. Right? Do you need me to do that one? Okay. So I distribute the 3 through, right? So I've got 2 plus 9x equals 12x plus 3 minus 1. So I'm going to subtract 12x from both sides. I'm going to make this bigger. And I'm going to subtract 2 from both sides. So I'm going to get negative 3x equals 0. Okay? Divide by negative 3. X equals 0. When I get x equals anything, it's conditional. Right? And then, of course, D is the same as number 1 because I made a mistake again. You know, hey. So that was thank you, contradiction. Contradiction. Okay? Is there any questions? How do you guys feel? Not too terribly bad? Okay, we're going to talk about Canvas and where your assignment is